Now we have the square root of 7 times this, or two terms, right? Square root of 11 minus square root of 5. And just as you might think, we are going to be allowed to use distributive property and distribute the square root of 7 throughout. So again, these index, they match, so we can multiply inside of the square root sign, and 7 times 11 is 77. There's no perfect squares in there, right? Factors, minus, and then 7 times 5 is square root of 35. Again, now these cannot be subtracted because they're not like terms anymore. The radicands are different, so this is your final answer. Number 4. Well, what do you think? If you guessed that we're going to do some sort of foiling, first, outer, inner, and last, then you are right. So let's do that, okay? So the first is square root of 5 times square root of 5. Square root of 5 times square root of 5 is the square root of 25, which is just a 5, isn't it? So this guy we're actually going to be able to just simplify right off the bat as 5. All right. Then the outers are square root of 5. So the outside is the square root of 5 times the square root of 3. And so that's plus square root of 15. Okay, now we're going to do the inside. Negative 11 root 3 times the square root of 5. So that's going to be equal to negative 11, or subtract 11 square root of 15. And the last is going to be negative 11 root 3 again with the root 3. It's negative 11 square root of 9. Okay, so in here, if you notice, we have these two like terms. So these are the like terms. That's a positive root 15 and a negative 11 root 15. So that would be negative 10 square root of 15. And then the other thing I want you to notice is over here, you've got that root 9, right? Square root of 9 right here. So you're going to multiply together the 11 times 3, right? Because that's the square root of 9, so that's a negative 33. And now you have some new like, these two like terms. You've got the 5 and the negative 33. The negative 28 minus, and then the 10 square root of 15. Okay, so look at this guy. Square root of 6 minus square root of 5 all squared. Okay, if you thought write it down twice and FOIL, you were right. Okay, because we cannot distribute that 2. That's not a legal move because we have two terms. Okay, so square root of 6 times the square root of 6 is the square root of 36, or 6. And then square root of 6 times a negative square root of 5 is negative square root of 30. And then negative root 5 times a square root of 6 is another negative root 30, right? Square root 30. And then negative root 5 times a negative root 5 is a positive square root of 25, or 5. Okay, do we have like terms? Yes. We have these two middle terms. That's going to give us, remember there's an invisible 1 here? I'm just going to remind you, right? There's coefficient here and here. So negative 1 and negative 1, so that's a negative 2 square root of 30. And then you also have the 6 with the 5, right? Add those together and that's 11. All right, we're going to go to the next one. This one looks pretty ugly, but again, we are stuck. We have to write this down twice. Okay. And we have to do some foiling. We have to distribute twice, right? So let's get a different color. So 2 times 2, oh, that's thick. 2 times 2 is 4, right? Now you're going to multiply 2 times this 10 square root of 2c minus 4. And the way to multiply that is you multiply the 2 times the 10, because they're out. The 2 doesn't have a radical. So it's going to get multiplied to the 10, which is outside the radical. That's plus 20 square root 2c minus 4. Okay. And then now we're going to do the inside. And that's another 20 square root of 2c minus 4. And then we have the, okay, this one's going to be interesting. So we're going to multiply the 10 times the 10, which is 100, and a square root of 2c minus 4. Square root of 2c minus 4 times another square root of 2c minus 4 is equal to, put a parentheses, 2c minus 4, right? Okay, so let's talk about that. So the square root of 2c minus 4 times another square root of 2c minus 4, that would be equal to the square root of 2c minus 4 squared. And so now you have a perfect square, so these undo each other, right? Squaring and square rooting, so that's how come we end up with the 2c minus 4. So we can actually distribute this 100. I know there's a lot of algebra to this one, and we can add those two together, right? So I have this 4 plus 40 square root of 2c minus 4, and then I have plus 200. Oh, that looks kind of weird, doesn't it? Let me erase this. Okay. Then you have here the plus 200c, and then you have the minus 400. And then there's these two like terms. So you get negative 396. I know this is weird, isn't it? Let's put that 200c in front. Just, you can do it any order, you know that. Plus 40 square root of 2c minus 4. In any order, these three terms. Okay. Let's go to the next couple here. To the last two. Okay. So again, we're going to FOIL 4 square root of 5 times another 4 square root of 5. Multiply the 4 times 4 is 16. Square root of 25, which is 16 times 5. I'm going to put the parentheses. I'm going to multiply those two there. And that's going to be 80, isn't it? Okay. Then the outside is going to be 4 times negative 3 is negative 12. Square root of 5 times 3 is 15. Okay. Then the inside is positive 12. Square root of 15. Isn't that interesting? That these two middle terms are going to give you 0. Do you remember why that happens? I'm going to tell you in a minute. Okay, and then I have 3 square root of 3 times a negative 3 square root of 3, which is negative 9 square root of 9. Oh, square root of 9 is 3, so negative 9 times 3. Right? So, which is a negative 27. So 80 minus 27, 53. So look at this. No square root part, right? This is beautiful. Isn't that great? Did you notice there's no square root part? It's a nice whole number. It's a nice integer. There's no whole number, or let's call it an integer. It might have been negative, right? No square root part. Why did that happen? Why did the middle terms go away? Because, go back and look at the original. Do you remember what we call when we have the same two terms but with different middle signs? Those are conjugates. You saw that in a previous chapter. And that's how we get nice numbers with no square root. Okay, look at number 8. Did you notice that these are conjugates too? These are conjugates. That means I'm going to have no middle term, right? I'm going to have no, the outsides and the insides are going to cancel, right? So that means that I know that this is the same as 3 square root of x squared minus 6 square root of y squared. Do you remember that? Do you remember that if you multiply together conjugates, you get the difference of squares? So I'm going to use that shortcut here. Or remember, you can FOIL this, get the same thing. Okay? But let's see, how do we square this? Now notice, this is a single term, so this would be a power rule. So you would square the 3 and you would square the square root of x. And the 3 squared would be 9, and the square root of x squared is x because these undo each other. These are inverse functions, right? So that's an x. And then now we have minus, we have 6 square root of y squared, right? So 6 squared, square root of y squared. 6 squared is 36, and the square root of y squared, these undo each other, and so that's y. And again, notice we have this nice binomial, no square root. We're going to use that in the next section. You will use number 7 and number 8 when you divide radical expressions. Okay.